Figure 26.29 shows a rectangle metal frame PQRS placed in a uniform magnetic field. Okay. And then 4.0, they have a magnetic field line 4.5 times 10 power minus 3. We have several questions here, A, B, C, and D. So let's check one by one. Start from A. Number 6, A. The magnetic flux density B is 4.5 times 10 to the power minus 3, and current the metal frame is 2.5 ampere. A. Calculate the force experienced by side PQ on the frame. Okay. Force on the PQ1. This is B times I times L. L the PQ1. So B equals to 4.5 times 10 to the power minus 3. And then I is 2.5. And then length of PQ is 7 centimeter. We change into meter. Internet. 7.5 times 10 to the power minus 2. Because change or convert into meter. So I will calculate first. 4.5 times 2.5 times 7.5 equals to 84. This is 8.4. This is 8.4 times 10 to the power minus 4 in Newton. That's it. Okay. This is for a question. This is number 6 for a question. Using F equals to BIL. On the side PQ, the L is length for PQ. Okay, let's check question B. B is suggest why side QR doesn't experience of a force. Because this is not in right angle, or the angle, because this is the angle, between B and L is this is in 180 degree. So sine 180 equals to 0. So there is no experience of the force. Not only 180. or zero, yeah, when the between B and L is in the one direction or opposite direction, so there is no force. Okay, B. Yeah. Then let's check question C. Describe the motion of the frame immediately after the current in the frame is switched on. Okay, we have Fleming left hand here. So we can see on the PQ first, yeah, when we have the current is downward, yeah, and then B is going right, yeah. This is like this is B, yeah, and this is I. So they will have force. We use this is like dot, yeah. Uh, Force is dot, yeah. It means uh, out of the plain paper, yeah, out of the plain paper. So same thing with on the other side in SR, yeah. SR they have B is on the right side, yeah, but current uh, upward, yeah. On this section, yeah, you may use the left hand rule, yeah, between I, B, and F, yeah, yeah. This is I use thumb, and then B use apa namanya? Sorry, with jangan balai. So B I, yes, correct. So the this is the cross one, yeah. This is the cross one. FBI, yeah. Force B and I when I is upward and then B is this is cross and this is dot. So we have like the rotation of move is like anti-clockwise, yeah, like that one. They come here and they have uh, the like this one, yeah, the rotation, yeah. Because this is cross, so they have go inside of the paper, and this is dot, so go out, yeah, of the plain paper, yeah. So the answer in C is this is anti-clockwise, yeah. Okay, the answer is anti-clockwise. One more question, yeah. Calculate the maximum torque, yeah, moment exerted about an axis on the parallel to side PQ. Okay, here maybe D. Torque is force times D. Force on the PQ is 8.4 times 10 to the power minus 4, and D is, yeah, D is like a half of length RQ, yeah. Why? Because this is like this is on the pivot, yeah. This is like pivot. or center of rotation. So this is something with 2 times 10 to the power minus 2, yeah. 2 centimeter. So moment is 16.8, yeah, times 10 to the power minus 6, or maybe 1.7, yeah, times 10 to the power minus 5 in Newton meter. Okay, that's it. Oke ya, kita lanjut lagi. Check the question 7. Number 7, figure 26.30 show current carrying wire frame, yeah, placed between a pair of magnetic on a yoke. A pointer is attached to the wire. Wow. Okay. A current 8.5 ampere in the wire causes the pointer move vertically upward. A small paper tip is attached to the pointer. The weight of the paper tips causes the pointer to revert to its initial position with no current and no paper tip. The paper mass is subsequently found to be 60 milligram. Okay. The section of the wire between the poles and magnetic has length of 5.2 centimeter. State the direction of magnetic field. Wait. Wait. Occur. Oh, I know. Uh, this on the question A about direction of a magnetic field. Yeah, here. We can highlight about uh, the weight paper cross pointer to this position. Oh, this is here. The wire move vertically upward. It's mean the force. Yeah, it's mean this is force. Yeah. Magnetic force. So when we draw it, yeah. Oh, we find about the current direction force here. You see this. This is a positive sign. Yeah. So current from this polarity. Yeah. When this is close and the current it will be moved here, here, and then go here. So this is like when we draw it. Yeah. Force is upward. Yeah. This is force, and the current is good to us. Yeah. This is like 3 dimension. Uh, this is I, and between F and I, of course, right angle. Yeah. This is right angle actually. Yeah. So when we use right hand rules here, this is B, this is I, and this is force here. So like this one. You can see here that this is I and this is force. Yeah, force is going up and then I is come to us. Yeah, So B is going right. Yeah. This is the B one. Mm. We use red line. This is B. Or well, if we draw it in two dimension, yeah, this is force, yeah, and then B is here, and electric current is dot, yeah. So like dot. This is I, yeah, I. Okay, that's it. Yeah. Let's check question B. Calculate the force on the wire due to magnetic field when the carries current 8.5 ampere. Okay, we try to find about force. Force is B I L. Yeah. Wait, we don't have B. Oh, we have about weight of the mass paper. So this is same thing with weight. Yeah. This is same thing with weight. This is actually same thing with weight of paper. Yeah. Or equals to mass time gravitational acceleration. Yeah. They have mass 60 milligram. Yeah. 60 milligram. Yeah. Is convert into kilogram uh, times with 10 to the power minus 3. Yeah. And then gravitational acceleration is 9.8. Yeah. So 60 times 9.8. 5.88. Yeah. Or 0. This is 0.588 Newton. We use take from mass of paper. Yeah. Then question C is calculate the magnetic flux density of the magnet field between poles of the magnet. So after we know about force, yeah, that force equals to B I times L. Yeah. So from this, yeah, B equals to force divided IL. Yeah. Or B equals to force is 0.588 divided I current is 8.5 and then times L length is the length is 5.2. Yes, 5.2 centimeter. We convert into meter. So we divided 8. Then oh, this is so big, yeah. 7.8. 7. Oh, sorry, 7. This is 7.5 times 10 to the power 1 to 4. Yeah, Tesla. 7.5 times 10 to the power 4 Tesla. Yeah, that's it. Okay, this is question C. We find about B. Yeah, the density magnetic flux. Yeah. One more question, D question. Describe what happens to the frame if low frequency alternating current pass through the wire. Oh, um, sorry, maybe I will skip it this year because uh, you don't apa, yet uh, learning about alternating current. Kita belum belajar alternating current ya. Jadi Bapak skip aja dulu ya. Ya, oke, kita lanjut lagi ya. Let's check question 8. Sebentar di sini. Oh, ada ya. Kita lihat 8 aja. Okay, we have two question 8, A and B. So we try to finish this year. 8A, the size of force acting on the wire carrying a current in a magnetic field is proportional to size of the current in the wire. Yes. With the 8 diagram, yeah, describe how to this can be demonstrated in the school laboratory. Oh, I repeat again, yeah, the size of force acting on the wire carrying current in the magnetic field, yeah, is proportional to size of the current in the wire. Oh, yeah. We can use power supply, yeah, actually, when we draw it the diagram, yeah. This is like, let's say, uh, diagram. Mm, let's say this is power supply and supply about current, yeah, with the voltage. This is like, so this is positive sign, this is negative, and we use like dynamo, maybe, yeah, dynamo, uh, like this one. This, yeah. And we give like a porous, ya apa ya, dikasih semacam kayu di sini. Uh, dia berputar tapi tidak lompat ya. Ya semacam ini ya. This is uh, like power supply. Aduh. With the several voltage, yeah. Power supply like 3 volt, yeah, 6 volt, 9 volt, and 12 volt. So different voltage, different current, yeah. So different current, it will be make different rotational speed, yeah. This is, oh iya, magnetnya belum ini. We use here, let's say, here is magnet. This is also magnet. Oh ya, magnetnya mungkin seperti ini, yang magnet U. Ya, we have magnet U ya. Oh, yes, gambarnya kurang bagus. Ya, let's say this is north, ya, and this is south. Ah, so from a different power supply, a different voltage on the power supply, it will make different current. Yeah, and then a constant magnetic field. Yeah, so it makes the rotational of this uh, miniature of dynamo. Yeah, miniature of dynamo. Yeah. So with the aid of a diagram, describe how to can demonstrate it in the school laboratory. Ya, maybe diagramnya seperti ini kurang lebih ya. Mungkin gambarnya yang lebih bagus lagi. Artinya ini ada power supply ya. Kemudian ini ada bikin kawat supaya rectangle seperti ini, tapi dibikin poros. Nah, memang agak susah bikin poros ya. Dan kemudian ada magnet di sini. Bisa menggunakan magnet U. That's it. Oke, kita coba lihat yang B question. Ya. A certain point on Earth's surface, the horizontal component of Earth's magnetic field is 1.6 times 10 to the power minus 5 Tesla. Base wire 3.0 meter long and weight 0.02 Newton. Yeah. Lies in the east-west direction on a laboratory bench. When the current flows in the wire just lift off the surface of bench. Yeah. State and direction of the current on the wire. Whoa. Okay, we check one by one. Yeah. Certain point or surface horizontal component. Horizontal component. This is a piece of on the east-west. Whoa. East-west ya. Oke, gini. Let's say this is Earth. This is Earth. And they have magnetic field. Let's say seperti ini. B. And then ini dia east west. Oke. Seperti ini deh. I. But this is right angle ya. I in east west. Aduh, tulisannya. Sorry ya, internetnya kurang lancar nih. I in east west. Timur ke barat ya. Itu kalau timur barat kenapa miring? Sorry ya, ini begini aja. Maybe ini east, ini west ya. Oke deh, ini east, ini west. Okay, we use right hand rules. Yeah, B is up and then I is to left. So the force is cross. Yeah, this is cross nih. Yeah, force. So cross its mean gimana ya? Timur, timur tenggara. Oh, ini south ya. Force itu south ini. Force in south ya. Or north to south ya. It mean north to south karena ini east west berarti north south. This is north. South. One more question. Calculate the minimum current needed to lift the wire bench. Yeah. One more. Yeah. I equals to force divided B L. Yeah. Force, this is 0.02 Newton. And then B we have 1.6 times 10 to the power minus 5. And then length is 3 meter. Yeah. So, coba kita hitung. 0.02 divided 1.6. Divided 3. So, oh, so big current. One, 2.4. Yeah, 2.4 times 10 power 7 ampere. Oh, so big, yeah. Because on the earth, yeah, because on the earth. Okay, that's it, yeah. Okay, that's it.